Greetings and welcome to Session 4, Understanding Note Position Numbers. My name is Jerry and I'd like to begin by reminding you from Session 1 that the primary goal of this learning series is to get you forming chords as soon as possible. As we move closer to that goal, we need to understand another important concept known as note position numbers, especially since every chord is defined using them. As you can see in this map, this will help remind us of where we've been, where we are, and where we are going. My experience has revealed that note position numbers may be the single most important music theory concept to learn, as it will expand your vocabulary of how chords are formed by tenfold. And yet it still seems to be one of the most misunderstood topics. So let's begin by building upon what we've learned back in Session 3 about chromatic octaves, something relatively easy to understand. To briefly recall, a chromatic octave is any series of 12 consecutive notes starting on any note you wish. For example, let's look at the A chromatic octave. Since the start note becomes the name of the octave, here's what those series of 12 notes look like. This would be A sharp, B, C, C sharp, D, D sharp, E, F sharp, G, G sharp, and A. That's a chromatic octave. A very easy, consistent, and straightforward concept. To help us understand note position numbers, I have broken this topic down into 5 learning points. They are: what are note position numbers? Why note position numbers are important to know. How are note position numbers assigned? When are note position numbers used? And the process of using note position numbers. Let's get started by first looking at what note position numbers are. As the name suggests, note position numbers are used to identify the positions or intervals between notes in chords and scales, and must be used as a complete set of numbers. Their names are note position number 1, note position number flat 2, note position number 2, note position number flat 3, note position number 3, note position number 4, note position number flat 5, note position number 5, note position number flat 6, note position number 6, note position number flat 7, and lastly, note position number 7. And as a sidebar of curiosity, I was unable to determine exactly who or when these numbers were created, but it appears they have been around for decades, so this is what we have to work with. Thus, whenever I say note position numbers, I am referring to this entire set and sequence of note position number names. And you may as well memorize them, as they never change. As shown here, you can see that 7 of the 12 note position numbers are named with whole numbers. However, I want to point out that many beginning musicians make the erroneous connection that the whole note position numbers are only assigned to white notes. As we will soon see, this is true, but only when using the C chromatic octave. The other 11 chromatic octaves will have whole numbers assigned to black notes as well. My ultimate point is that I want to be sure that you understand there is no relationship between whole and flat note position numbers and the color of the notes they are assigned to, as I did many years ago. In this slide, you can see the 5 flat name note position numbers and their placement between the whole numbers. In fact, and generally speaking, 3 of these flat note position numbers are seldom talked about because you will rarely, if ever, see chords using the flat 2, the flat 5, or the flat 6 note position numbers. But the other 2 of the 5 flat note position numbers are routinely used in dozens and dozens of chords that are formed with the flat 3 and or flat 7 note position numbers. Notice I have them circled. Regardless of their individual frequency of use, we still have to account for all 12 of the note position numbers as a complete set of numbers, so we can't omit any, as you'll see here soon. Let's now take a look at the C chromatic octave of notes. Obviously, we begin with the C note, C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, and B. And then we wanted to start again, we would start, which would be the same way here. So this would just be the next higher octave and etc. But thus, there's always 12 notes in any one chromatic octave, no matter which note you start on. So you could start on any one of these notes and then go up. So we'll take a look at those other examples here in a little bit. Now that we know what note position numbers look like, let me give you 2 reasons why they are important to learn, especially since hinting earlier that understanding them will expand your knowledge by tenfold when it comes to forming chords. Reason number 1, note position numbers automatically identify distances or spaces between notes for us in both chords and scales. And as you learned back in session 3, we call these distances note intervals. Thus, note position numbers are like a coding language for identifying note intervals between every note of every type of chord, no matter what the chord letter name is, which is a huge advantage in learning music theory. And as much as I support absolute beginners in learning how to read music by taking formal piano lessons to advance their skills, learning to read sheet music will not substitute for understanding note position numbers as related to chords, because a music student learns to read individual notes on a sheet of paper, not specific chord names. Veteran music readers do actually play specific notes that make up specific chords, but they aren't focused on learning chord names per se, nor how chords are structured and formed. Nothing wrong with that, but if readers don't have sheet music in front of them to play notes, they are stuck. Knowing how chords are created and played is a different skill set, which is what I am attempting to convey. So short of learning how to read sheet music, which may take years of study and practice, non-readers can simply use note position numbers for forming all chords. Having both skill sets is great, but not necessary. Reason number 2, for learning why note position numbers are important to know is that learning how the 12 note position numbers work, you will be able to form hundreds of chords without having to memorize every note of every chord and every pitch of a chromatic octave. In fact, not just hundreds of chords, but it will apply to every chord. And you won't have to intentionally memorize all these dozens of notes and note finger shapes and notes to chords, similar to how guitar players typically learn chords. So if you choose not to learn the note position numbering language, you will be limiting yourself to learning chords by memorization or finger shapes alone, missing a great opportunity to use note position numbers as a tool to form any chord pretty much on demand. And by the way, you might now be thinking that since we have already learned note names back in session 2, why can't we just look up the note names that need to be played to form a certain chord and not use note position numbers? Well, the answer is you can by buying chord charts or chord books such as this chart. But the problem is that most of these resources only contain a limited number of chords. And those chords that are not addressed in charts or books leave you back at square one. The better news, though, is that there are other resources, particularly on the internet, that do provide chord notes, such as the 8notes.com website. That's 8notes.com website. It is an excellent source where you can look up chord names from your computer or mobile device, and it instantly gives and shows you the notes of that chord, thus making it quick and convenient. And there are many other electronic sites that do the same thing. However, these types of charts and websites do not necessarily explain how chord notes are derived, which pushes you back again to memorizing everything. In short, there is no good substitute for learning note position numbers. And if there is ever anything worth memorizing in music theory, I recommend it should be the 12 note position numbers rather than having dozens and dozens of chord notes and shapes to remember. Now let's see how note position numbers are connected and assigned to chromatic octaves. Not just certain chromatic octaves, but any chromatic octave you choose. First, remember that note position numbers must be assigned as a complete set of numbers and can start on any of the 12 notes of a chromatic octave. They must also be assigned in sequence, without omission, without additions, or without exceptions. Since there are 12 notes in any chromatic octave, and since there are 12 note position numbers, these assignments easily connect and align one for one. And remember, note position numbers do not care which of the 12 chromatic octave notes you choose as the root or start note for a chord, since they are all assigned using the same process and sequence. As you might guess, note position number assignments begin with note position number 1 assigned to the root or starting note of the chromatic octave, which then is the same note letter name of the chords you wish to form. For example, if you want to form an A major chord, you assign note position number 1 to the A note of the chromatic octave and continue the note numbering assignments to the 11 next notes. So let's look at that and see if we can start with those assignments. So if A is the start note, this will be the start of an A chromatic octave, and we'll assign the note position number. So this is note position 1. This then would be note position flat 2. This is note position 2. This is note position flat 3. This is note position 3. This is note position 4. This is flat 5. Note position 5. Note position flat 6. Note position 6. Note position flat 7. And then note position 7. So that gets us our 12 note positions. 1, flat 2, 2, flat 3, 3, 4, flat 5, 5, flat 6, 6, flat 7, and then note position 7. And that's obviously in the chromatic octave of A. So let's take a look at some other examples. Let's try and go back to C, probably the most often used, and yet the only example where the notes and the note position numbers and notes line up more perfectly in color. And this is normally the example that everyone gives you, which is why it can be misleading in the sense that this lines up so perfectly. So let's see in terms of whole numbers and the flat numbers. So if we take the octave of C here, and we're going to go up to here. So let's assign note position 1, which is on a white, and that's a whole number. And then this is flat 2, which happens to fall on the black key. This is 2. This is flat 3, back on one of the black notes. Then this is note position 3. And then this is note position 4. This is note position flat 5, 5, flat 6, 6, flat 7, and 7. So when all said and done, all the whole numbers in this example, and this is the only only time this works, is in the key of C, or the C chromatic octave. This is 1, 2, 3, 4, 5, 6, 7. So all those examples you see make it easy if they're using C as the example, and that is a good teaching platform. So all the white notes are whole notes, and all the black notes are the flatted note position numbers. So again, note position 1, flat 2, 2, flat 3, 3, 4, flat 5, 5, flat 6, 6, flat 7, and 7. And then that's misleading in the sense that you might think that's the only octave that you can use, but that's not true. You can use any octave. So I'll continue to point out, so as good as C is a great teaching platform, don't let that mislead you to think that all of the whole numbers are going to line up on the white keys and all the flatted note position numbers are going to line up on that. We actually saw that in A just a minute ago. But let's take another one just to be sure. So let's assign note position numbers to the D chromatic octave and see how these numbers shift again. So if we start here with D and go flat 2, so here's 1, flat 2, 2, flat 3. And notice now that that is on, the flat is on a white note. So this is flat 3, 3, 4, flat 5, 5, flat 6, 6, and then flat 7, and then 7. So that would be an example of the D chromatic note position assignments. So that's a good example. So as we stated previously, remember that there is no correlation between whole note position numbers and the color of the notes. Obviously, whether it's whole or flat, there is no correlation between those numbers, the note position numbers, and the color of notes. And also remember that this C octave is the one, that's the only example. All other start notes you'd start on would have some odd combination of white and flat key notes related to the colors of that. Let's do one last example here, and I'll go back here and let's take an F sharp. In this case, we're going to, the start note is starting on a black key, which still won't matter. So if we use this F sharp as note position 1, then this is going to be note position flat 2. This is note position 2. This is note position flat 3. Note position 3. This is note position 4. This is note position flat 5, 5, flat 6, 6, flat 7, and then 7, and then we're back up to the octave note we started with, the F sharp note. So hopefully, although we started on a black note, notice that those numbering assignment and the process is the same. So it doesn't, the note position numbers don't care which letter note you start on. So hopefully these examples give you a full understanding of how note position numbers are assigned. Although a pretty straightforward process, it does take some time to get comfortable with using note position numbers. Near the end of the session, I'll give you a quick glance to show that note position numbers actually extend into a second and higher octave of notes, specifically note position numbers 8, 9, 11, and 13. But for now, we'll keep our focus on just the first chromatic octave, and if we can get that under our belt, the rest of those extended numbers will be very similar and the same and make sense. Now, to better explain when note position numbers are used, let me introduce an important term that will be useful and used over and over from this point forward. The term is chord formula. Although some refer to it as a chord spelling, both mean the same thing. As the name suggests, it is a formula which, in the case of music theory, defines the specific notes that are required to form specific types of chords. Because chord formulas are expressed with note position numbers instead of individual letter note names, this is when understanding note position numbers becomes very important. As you see, typical chord formulas are written or spelled using note position numbers such as 1, 3, 5, which is actually the code for the major chord type. And while we're here, I might add that the first 3 note position numbers in any chord formula are generally considered its triad spelling and is basically where all chords begin their life. The 1, flat 3, 5 note position numbers you see here is the code for a minor chord type. And then the last example, the 1, flat 3, flat 5, 7, is the code for a diminished 7th chord type. These, remember, are all note position numbers that we're looking at. Now, I'm not attempting to overwhelm you here, but you will learn later just how easily these and all chords like them can be decoded by using note position numbers. So for now, this is just a quick overview about chord formulas and note position numbers. We'll take a much deeper dive in session 6 about chords. Thus, when we look up a chord formula for a specific type of chord, we simply plug in the particular chord letter name to start the note position numbering assignments. That chord letter name will tell us which note we start on in that sequence of naming the note positions in that octave. Remember, the chord formula itself does not know or even care which chord letter name you might wish to form. Its only job is to define the note position numbers to form your chosen chord type. But the real beauty of understanding and using note position numbers is that we can eliminate having to memorize all those hundreds of chord notes and chord shapes as we mentioned earlier. Now let's see how note position numbers are used in a typical application using a make-believe song. Obviously, in any given song, you typically would only be dealing with a few different chords to translate from note position numbers to chord notes. Let me explain this process from a 5-step perspective. First, in step 1, as you see here, you would need to identify all the chord names from your song of choice, either by asking another musician, or the internet, or from sheet music. For example, let's say our make-believe song has only 3 chords. And in this example, let's say that these 3 chords are, in no particular order, an E flat major, an A minor chord, and a G major chord. Although there are 3 letter name chords that I just mentioned, there really are only 2 different types of chords, a major type and a minor type. So just make a mental note of this for now. This is step 2. To keep things simple, let's focus only on the E flat major chord, only because it was mentioned first. As you should know by now from previous examples, if we write each note of the E flat chromatic octave, it looks like this. It's the notes E flat, E, F, G flat, G, A flat, A, B flat, B, C, D flat, and then D. Those are the 12 notes of the E flat chromatic octave. So that's basically where we'll start here with the first chord in this example. For step 3 in this process, we can see the note position number assignments for this E flat chromatic octave of notes. Notice that all we have to do, if using a table format like this one, is to begin note position number assignments on the first note letter and continue uninterrupted. Thus, these note position number assignments are unique only to the E flat octave of notes, as they are unique to any other chromatic octave of notes. So using a simple table like this can help us just keep things nice, neat, and aligned. In step 4 of the process that I am describing, we now need to look at the chord formulas for each different type of chord and write them down using note position numbers as seen in this table before. So officially, the chord formula for a major chord type or major type of chord is 1, 3, and 5. Those are note position numbers, and they're always that. Anytime you see that, that means that is a major chord. You can see then in the chart the minor chord its formula is 1 flat 3, 5. So now that we've got these formulas, the correct formulas, we looked them up regardless of where we got them from. So we only have to translate these into note letters to form the chord. But while we're here, those two different chord types, that of the major and minor, if you look closely between those two in the chart, and I mentioned it a second ago, the only difference in those two is just one note there in the middle. The major has a number 3 note position, and a minor has a flat 3 note position. That's the only difference in those two chords. And that means that technically then, when you start forming chords, when we get into session 6 and really start getting into form, that's the only difference that we have to do, is to change our fingering from note position 3, drop it backwards to a flat 3 position, and now we've got a different chord type. And interestingly, between the major chord type and the minor chord type, that makes up about 80% of the types of chords that you will typically play. So keep that in mind. This is a major step here in kind of understanding the chord formulas. My last step in describing this 5-step process is where we now only have to focus on the 3 note position numbers of the chord formula, and then thus the notes that they were assigned to initially. You can see this chart we brought back again, so we built that. So we started with the octave of notes, then the note position assignments, and now because we knew the chord formula, we're still using this E flat as the first chord example, we can see that we need to know only note positions 1, 3, and 5, which is the formula, and then you can see the resulting notes. It's the same as where we started. So the note position 1 in this example is an E flat note. Then moving to the right, then we see that the note position 3 is the G note, which is the second note of that chord. And then the 5th note position note is a B flat. So basically, to make up an E flat major chord, we need the notes E flat, G, and B flat. So anytime we play those 3 notes, that is an E flat major chord. Major because that's the formula we use for a major type of chord, and in this case the specific chord name was E flat. So all told, it is an E flat major chord. And that's really how simple this is, and it's really how the note positions work to help us kind of be able to chart and know for sure. Now later you don't have to maybe do it all on paper, but you'll get used to using these note position numbers, and you'll be able to start doing that automatically without having to put it to pencil and paper. Now let's look at the second chord in our make-believe song, the A minor chord, and we'll see that and use the same table. I've only had to change the top row of notes from the E flat to the A chromatic octave of notes, as you can see here. Pretty simple process. And then in the second row, we didn't even have to change anything. Those are the note position assignments there. And then the third row is we did change this because this particular chord is a minor chord, an A minor chord. Thus, the chord formula is 1 flat 3 5. You can see those listed there in the chart. And then once we do that, all we have to do is to bring down the top row in those note positions. So basically an A minor chord, as we can see here, is made up of the notes A, C, and E. And it's really that simple. So anytime a keyboardist is asked, or I'm asked, or you're asked to play an A minor chord, we will eventually learn by practice that it's an A, C, and an E. Without striving to memorize that, this is a way we can double check using note position numbers to get us there. And with enough practice, then all of this stuff becomes pretty routine for you. But this should help us. So that's our second chord in our make-believe song. And now the third chord in our make-believe song here. Let's use the same process that we've done in the previous two. And in this case, we're looking for a G major chord. So again, you can see that the chart here is the same chart. We just took the row 1 and replaced with a G chromatic octave of notes, G all the way up the line there. Then the note position numbers stay the same. And back now we're on a major chord type because this was a G major chord. So now we plugged in 1, 3, and 5 in the third row. That's the formula for a major chord. And then thus the resulting G major chord notes are G, B, and D. So every time we play the notes G, B, and D, we are making a G major chord. This is where maybe a music reader may not know that it's a G major chord. They're just playing the notes G, B, and D. They just hadn't made the connection necessarily to that unless they've studied it. So in this process example, I hope you now understand how note position number assignments are converted to chord notes. And until you get familiar with the process, I suggest you continue writing maybe this information using these kind of charts down as I have, so that you can kind of see these assignments easier till you get used to it. But with enough practice, you'll be able to process this information mentally and visually without paper and pencil. So although the note position numbers are a rather easy concept to grasp, it does take a bit of time to get comfortable with them. So now when you see chords containing numbers such as A6, C ninth chord, F sharp minor 7th chord, B flat major 7th chord, D 7th sharp 9, G 7 sharp 5, or an E major 11th chord, you know and need to know instantly that any of those numbers that are listed there as part of a chord name are note position numbers. That's the point I'm trying to make here. So they're not some other kind of numbers that are bopping around or changing on you. Those are note position numbers. So that's part of the code that will help us decipher and decode through the note position numbers exactly which notes to play for any particular chord, not just these few examples that you're looking at here. So don't be intimidated, because we'll see that we've got, and this is working on not just now, but we'll continue to fully explain all of this, particularly as we get to session 6, which is the big one that will put all of this information together about chords. So we're getting closer. To bring this session to a close, I want to show you that there are note position numbers that extend beyond the 7th note position to the 13th note position, which is all you will ever need in forming chords. This is necessary because there are many chords used in rock, pop, and country songs that include versions of 9th, 11th, and 13th chords, which are known as extended chords, extended beyond the 7th note position. For now, though, I just wanted to introduce that exists, and we'll look at this closer later. Just keep this little table handy as a good cheat sheet and reference as we move forward. So lastly, while we're here, it's worth mentioning that chords are typically formed with odd note position numbers of 1, 3, 5, 7, 9, 11, and 13. These odd numbers kind of give us a nice note harmonies as they originate from major and minor third note intervals that many chords are formed from. Remember, we talked about how note intervals back in session 3 are, so this is a good example as we begin making advanced connections with puzzle pieces in the music theory arena. So let's wrap up this session. Understanding note position numbers is so fundamental in learning how chords are formed, especially since they are the traditional and most used chord forming language. And remember, what we hear in music is, in essence, based upon note intervals, and it is note position numbers represented in chord formulas that define those intervals for us. Hopefully, you are now understanding how and why note positions work in forming chords, serving as a coding format for being able to look chord types up and then be able to form them in any chord letter name. And as good as the note position numbering language is, it does require concentration to use efficiently until you get some practice time using the process. In the next session, session number 5, I'll show you a compatible and even more efficient note numbering language that will help prepare you even more in understanding how chords are formed. And as a reminder, you will be better served in my series of sessions by studying the topics in the order I have prepared them for you. Thank you for your time and attention. Please subscribe if you found this session helpful in your music theory journey as an absolute beginner. Before ending this session, I want to clarify something that might have been misleading in case you picked up on it. About 4 minutes ago, near the 32-minute and 46-second timeline, I shared a few examples of chord names and indicated verbally and in text that any numbers you see in these and any other chord names are indeed note position numbers. And that is correct, except a better way to describe a number 7 in any chord name is that it actually represents the flat 7 note position number and really not the 7 note position number. I will fully describe why this is in session 8. I just want to be sure to correct any possible confusion and/or misunderstanding.